Now, in this video, we are going to look at combinations of tangent and secant, but in this case, secant is odd. All right, so we've got tangent to the power 5, and we have secant to the power 17. Oh my God, who made up that problem? Can't be me, can it? Okay, so if secant is even, then the substitution is the other one, tangent, x. And if secant is odd, then you can try, and again, this does not always work, the substitution secant. Now, in my case, when I look at the powers, I only care about the power of secant. Secant is odd, which means that I'm going to use the substitution secant. So that's where I'm going to put that here. You should know that the derivative of secant is secant multiplied by tangent. Okay, so got that. So what's the point? Like, why would this work? So let me show you. You're going to take your integral tangent to the 5, secant to the 17, and you're going to split, take out one of each. So you're going to leave tangent actually will be to the 4th, and then secant will be to the 16th. So you're taking one out, and you're going to put that in the end. So I'm taking pluck one tangent from the tangent to the 5th, and then we're also going to pluck one secant from secant to the 17th. Why did we do that? Well, because this part right here will now become du. Right, which is what we want. Now remember that our substitution is secant. So secant to the power 16 becomes u to the power 16. But what about that tangent to the 4th? That's kind of there. And how are we going to express that in terms of u? Well, we have an identity. We know that tangent squared x plus 1 equal secant squared x. Now let's take one subtracted from both sides. That will give me tangent squared x equal secant squared x minus 1. Now, the unfortunate thing here, and because this one is a little bit more difficult than normal, we don't have a squared, we have power 4. So how are we going to deal with that? Well, that's the same thing as tangent to the 4th is the same thing as tangent squared times tangent squared. So this part right here becomes u squared minus 1, but you are multiplying it by itself. So tangent to the 4th is tangent squared times another tangent squared. And that gives you u squared minus 1 multiplied again by u squared minus 1. Now you're going to have to FOIL that. Okay, so you got to multiply it, or you might know how to take some a minus b squared. You might know that formula, but I'll just FOIL. So u squared times u squared, that's u to the power 4. Then we have u squared times 1, which is outer. That'll give me negative u squared. Then inner, that's another negative u squared. And last is negative 1 times negative 1, which is positive 1. Okay, so these two will be negative 2u squared. Okay, so now we finally converted this guy in something like this. Okay, so are we ready to integrate? We've done a lot of work, but we're still not ready. Why? Because we have a product and we cannot integrate a product by integrating each factor and then multiplying the results. You can't do that. So you have u to the power 16th multiplied by this expression. Man, these powers are huge. Okay, how do we do that? Well, we're going to have to multiply and use distributive law. Okay, so we're going to get power 16 and power 4. What do we do with that? Add them up. So you get u to the power 20 minus 2, 16 and 2, add them up, that's 18. And then u to the power 16 is what we got. And finally, we are done with this step. That was a lot. So this one is definitely more challenging. All right, then we're going to just go ahead and integrate each one. And that's just a regular power rule, so that's not hard. We're going to get power 19. Oh my God. Power 17. Wow. All right. So are we done? Almost. We just have to substitute secant in for u. So we've got secant to the power 21 You can put it in between, or you can put the whole thing to the power 21. Either way. Like you can put it like this. Doesn't matter. Okay, so put 19 in between, or put the whole secant to the power 19. And then here, again, doesn't matter how you put it. The answer will be, doesn't matter. It's equivalent.